Day 6 of Maker Advent, and we're a quarter of the way through already. Today's project day, so we've got Adafruit Circuit Playground Express, and it's a good board for just exploring CircuitPython. Now, if you don't know what CircuitPython is, it's a fork of MicroPython. If you know what MicroPython is, that's a fork of Python 3, but for microcontrollers. So CircuitPython is Adafruit's own version of MicroPython, to a degree, and it uses pre-written libraries of code, little modules that you drop into a libs folder on the drive, and this device, or any other device, including the Pico, that can run CircuitPython, will then instantly know how to interface with different things, so like sensors and lights on this board. If I drop modules into the library folder, it knows how to interact with them. I write the Python code, and away we go. Nice and easy. So I'm going to go to the product page for this. It's $25 for a Circuit Playground Express, and it comes with 10 mini NeoPixels. So NeoPixels, RGB LEDs, WS2812Bs, for everyone who knows their numbers. It has a motion sensor built in, LIS 3DH triple axis accelerometer with tap detection and freefall detection. So you can throw this thing around, you can tap it, and it can be used as an input. We've got a thermistor temperature sensor, a light sensor, so a photo transistor, and it can act as a color sensor to a degree as well, so you can have your own color detection. That's cool. It's got some speakers on it. Sorry, speaker, not speakers. It's not a surround sound system. And the speaker is just that tiny, it's that little thing there. That's a speaker, and it's quite punchy for its size. You can also plug in external speakers if you want. That's fun. Infrared receiver, a slide switch, a cuddly toy. Hang on, no, that's Generation Game. Alligator clips around the edges like a microbit, and it also does I2C, UART, all that sort of stuff. Great fun. Oh, and it works as cap touch as well, so capacitive touch. So you can have tinfoil circuits set up somewhere and have this integrated straight into it. But what am I doing with it today? Well, you'll see we have a globe of some sort. We also have Santa Claus in Lego form, and this is a Poundland snow globe. More like bowl for holding stuff in, but you know, whatever. Also, it's got a dimple out of the Death Star. Should really paint it like a Death Star, shouldn't I? Anyway, take the lid off. You'll see I've pre-marked a few things as well. And how'd you get stuff inside that snow globe? Well, that's removable. You put that on, you put this on, and you screw it all together, and ta-da, you have a snow globe full of glittery stuff that hopefully won't leak everywhere. I'm not going to fill it with water and snow globe stuff. I'm going to fill it with LEDs. So you can see Circuit Playground Express is showing some random colours right now. My goal is to put Santa Claus inside there with the lights underneath him to shine through and produce a nice light effect. And to do that, I've done a bit of work already. So you can see I've marked some areas for cutting. So that's there will be the back of this. So this is how I worked it out. There's a dimple for the Death Star super laser. If I put that on there and give it a half turn, and keep it in shot, there's the back of it in place. So I can cut that out, have the wire coming out, but have the Death Star super laser just here with Santa Claus in full control of it. There we go. We thought Santa Claus was nice, but no, he controls the Death Star super laser. So I'm going to do a jump cut. The mere blink of an eye for you is actually about 20 minutes of cutting and filing for me. The base, cut a chunk out. It's not pretty. This is a very quick hack because I'm looking at the clock and I've got to make work in 20 minutes. Oops. Anyway, that was just snipped with my side cutters. So I cut a chunk out of that, and also cut a chunk out my finger as well, but whatever. And I cut a chunk out of the back here. Again, not pretty, but functional for now. Get it working, then we can make it look pretty. So I'm going to do a test fit. So this needs to go on that away. There's a Death Star super laser down here by my little finger. Press that on. That's on. And tighten it, and it should line up. Bingo. And I've done a very, very quick check, and it's the size of that micro USB cable. So another jump cut, and I'll have that light inside here. Maybe even Santa Claus inside as well. Okay, so the lights are in the snow globe. I've also cut a chunk out of the inner like seal, which is what Santa Claus is going to stand on in a little bit. As you can see now, the lighting effect is quite pleasant. If I was to use some sort of diffuser at the base, some greaseproof paper or some very thinly made white paint, that would do the job to diffuse it. and do a nice glow inside here. But let's just go quickly to the code and have a look at what it's all about. So the code on the board is pretty simple. It's really just something from Adafruit's CircuitPython NeoPixel example, and you can see it looks very similar to MicroPython, what we're messing around with on the PyHut's Maker Advent Calendar. We have imports at the top, so we can import libraries for time, in other words, adding delays. Board, that's our GPIO connection to Circuit Playground Express. NeoPixel, we install a library called NeoPixel in the libs folder, which enables us to control the NeoPixels. And then this last one, random import randint, is the random library module has a class called randint. Is it a class or a function? Can't remember. Anyway, it has a feature where it's called randint, and that stands for random integer. And we're going to use that to generate a random number between 0 and 10, which is the number of pixels on here, and also 0 and 255. The RGB LEDs can have a value between 0 and 255 for each colour, so red, green, blue. And mixing those numbers, so 255, 0, 0, red, green, blue will be red on completely, so bright red, crimson red. 0, 255, 0 will be green, and 0, 0, 255 will be blue. So we've got two objects, pixel pin, which is the pin that the NeoPixels are connected to. In this case, we can use CircuitPython's helper, which is just board.NEOPIXEL, and we use a little variable here called numpixels, which just says 10. There are 10 pixels on this board. So now we need to say what the pixels do. So the pixels have an object called pixels, and we then say, okay, they are neopixels. We then pass it the pixel pin, which is the board's NeoPixel pin. How many neopixels there are. The brightness, in this case, I said it's a 0.1 because that's bright enough for this demo, but you can set it all the way up to 1, but be careful, it gets really bright. Then auto write false, which means it's not going to write changes as we do them. We have to explicitly say, do it. So, line 10, while true, do this forever. I, that generic variable that everyone creates, you know, for I in range, this and that sort of thing, is a random integer between 0 and the number of pixels minus 1. Why minus 1? Well, because if we set it to just number of pixels, there is a very slight occasion where it can go to 10. And because of the indexing system starting counting at 0, it goes 0 to 9 for 10 neopixels. So if we say 10, it goes, I don't know where that is, and just errors, and that's it, ends. So if we say number of pixels minus 1, great. Then we've got RGB, which are random integers between 0 and 255. So RGB, red, green, blue. This is our colour mix to make the lights come on at a random colour. Now we've got pixels I, which is the CircuitPython's way of saying, okay, pixels, your neopixels, choose a random one, I, so we've already got a random number between 0 and 9, and set that one to the value of RGB. But it's just 3 values stored in this little data object here, RGB. We then sleep for 0.1 of a second, and then we show. And that show is there to set the pixel colour to that colour. That's it, that's the code. So I'm going to set this to a really high speed now so we can see a change. So I'm going to save this, and I'm saving this code directly to the Circuit Playground Express. So if I save it now, the lights will flicker, and you'll see the colours are a lot faster now. Very fast compared to what it was before. 10 times quicker. So let's work out a way to get Santa Claus inside. And we can call day 6 done. Look, it's Disco Santa in his disco snow globe. Also, different camera angle, so I can get it all in shot and it looks decent. But yeah, Circuit Playground Express is inside, held together with blue tack. This is my Lego Brickhead Santa, and he's lit up. If I was going to do this as a permanent project, and I will at a later date, I'd use some sort of hot glue and all that to hold stuff in place, and also tidy up the wiring around the back. Conveniently, I've hidden that from the camera. Strange. But yeah, there we go. Day 6 done. Disco Santa.